Hello, good evening. My name is Miveadasha Vaishavi Renganathan, and me, along with three of my teammates, are going to be presenting about our legged robot L3. For the introduction of this legged robot, the project involves the design and development of an autonomous legged robot designed specifically for flat ground and for moving up a ramp of a maximum 30-degree slope. The main point of the project was to design a stable system that met the compact size criteria. The motion of the robot was provided by two DC gear motors, which powers the specially designed leg system. To withstand the strain of these operations, the robot was modeled and simulated in SolidWorks for optimal torque and weight distribution. The project validation involved the testing of the robot's grip strength and energy efficiency during the climbing and the descending process. There are three objectives that we focused on when making our robot. The first one is to achieve autonomous navigation, which is to program the robot to move within the line autonomously without any human intervention. The second objective is to design a stable and a functional quadrupedal system, which is to create a four-legged robot design with considerations for stability and movement control, utilizing DC gear motors for leg movements. The third and final objective is to integrate and control the electrical systems, which is by successfully integrating necessary components, including the two DC gear motors and also the power supply. Thank you.
Okay then, so this is the component that is used in our project, which is first entry bolt and nuts, structural material, switch, jumper wire, 3S 7.4 volt lithium ion battery, and a DC gear motor. Okay, now we go for the flow chart to explain the working system for the project. So it is a very simple step and process, which is first the switch is turned on and then the robot will move forward. Then we will uh, become when the option is either the switch is turned off or the switch does not turn off. If the switch is turned off, then the robot will stop moving. If the switch is still on or not turned off, the robot will continue to move forward until the switch is turned off.
So, hello everyone. I'm going to talk about the design and architecture for our legged robot. The Theo Jensen linkage and 11-bar kinematic chain serves as the primary leg locomotion mechanism for the robot. The quadruped structure utilizes 3D printed limbs and precision aligned articulated joints to ensure structural rigidity and also lightweight movement. The rotary motion from the central crankshaft is translated into a sophisticated overt walking path, mimicking biological movement with a single degree of freedom per leg. In the quadruped configuration, the structure maintains its constant static stability, allowing it to navigate a 30-degree ramp without losing its balance. In our robot, we have utilized two high torque DC motors to drive the mechanism, which essentially replaces the original wind powered design to provide consistent propulsion for climbing and track traversal.
Okay, I will explain the challenges we face on the build the robot. First, battery capacity limitation. When using a higher capacity battery, it increases the weight of the robot, which add the extra load to the motor. As the result, motor has work harder, leading to higher current draw, increase the power loss, and overheating during operation. Consequently, using lower capacity battery causes the battery to drain quickly, resulting in efficient power supply and reduced operating time. Second, short circuit issue. A short circuit occurs because the battery supply highest voltage than the required. This causes some of the wire to overheat and burn, leading to damage to the robot component and making the robot wear out quickly.